Okay, so we're going to try and get through examples 1 through 3 in this next section, but we'll stop if we need to. I'm going to start by reminding you guys about the deck of cards and how that works. Again, you guys should have these notes because we did pass these notes out before the spring break, so you should have them. They should be at least partially filled out. This section here should be filled out for everybody, but in reality, I know a lot of us have had a lot of things going on since then, so just in case, I want to make sure I review it. So there are 52 cards in a deck of cards. Within those 52 cards, they're broken down into 4 suits. The 4 suits are clubs, and clubs are a black suit. And those are going to be this one right here. Kind of looks like almost like a shamrock. Let me see if I can draw a little arrow here. And then we also have spades. Spades are also a black suit. We have diamonds, which are a red suit, and they are right here. And then we have hearts, which are right here, and those are also a red suit. Within each suit, there are 13 cards because 52 divided by 4 is 13, and those 13 cards start with an ace, which counts as a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you'll see Jack, Queen, King, and the Jack, Queen, King are underlined because the underlined cards are called face cards. So I'm just going to put a little happy bubble around that and underline this here. They're called face cards because they have actual faces on them. So bearing that in mind, as we look at example 1, it asks us if you were to draw one card from a deck of 52 cards, what would be the probability that that card would be an ace? That's the first question. And then what is the probability that it will not be an ace? That's a second question. So the probability of my selecting an ace, I'm going to name that the probability of ace, just like so. Again, we're drawing from the entire deck, so my denominator is 52. And to figure out how many aces, I'm going to come over here. So there are 4 suits, and each suit has these 13 cards, which means there would be 4 aces in the deck because I have an ace of clubs, ace of spades, ace of diamonds, ace of hearts. So that would be 4 out of 52. Please remember that you should reduce your fractions. 4 over 52 reduces down to 1/13. And you should also give me the decimal equivalent. My calculator is not handy at the moment, but I'll get that out for you guys and show it to you in future examples. When we go to the nearest thousandth, estimating to the nearest thousandth, it's 0.077. And that would be equivalent to 7.7% chance of us drawing an ace. To answer the second question, the probability of not selecting an ace, remember that our squiggle means we want a complementary event, that's the not. And so we would do 1 whole, and we would subtract what we just found in the problem above. So 1 minus the probability of an ace equals the probability of not selecting an ace. Since there are, again, this is equivalent to 52 out of 52. I'll just make a note down here. This would be equal to 48 out of 52. And that reduces down to 12/13, which is approximately 0 and 923 thousandths, or 92.3%. Okay, I'm going to go ahead and stop that there. Took a little longer with the explanation of the deck of cards.